Hi everybody, welcome back to the workshop. Today we're going to be talking about the AMA Beta. This is a rubber band powered free flight model airplane. And before we go any further, I have a confession to make. I do not know anything about rubber band powered free flight model airplanes. The good news here is that the whole idea behind the beta is that it provides a very simple and durable platform for people, especially kids, to learn about the basics of aero modeling. And those are fundamental lessons that can be applied if and when you transition to other areas of the hobby. So we're going to walk through all the steps necessary to get the beta out of the box and into the air, and we'll learn these lessons together. Let's get started. When you empty everything out of the box, you'll find several components. First of all, there is a printed instruction manual. And then we have two wing halves, a vertical stabilizer, and a horizontal stabilizer. And all of these components are made out of foam and they're decorated the way you see here. There is a plastic wing joiner. And here's the fuselage, which is basically just a balsa stick, but it also has a metal hook integrated into it, and that's for the rear of the rubber band. You'll also find that there is a slot cut into the rear of the fuselage, which is for the vertical stabilizer. And here we have a propeller, which is integrated with a propeller shaft, and also a mount, which slides directly onto the front of the fuselage. The Beta comes with two motors. One of them is 1/8 inch wide rubber. The other is a strip of rubber that is 3/16 of an inch wide. And both of these motors are more substantial than the dime store rubber band powered planes that you might have had as a kid. And to help take advantage of that extra power, the Beta also comes with a 20-to-1 winder. And this helps keep you from spinning all day turning the propeller by hand. Basically, for every single turn of the winder, you get 20 turns into the rubber band. Assembly of the Beta begins with the wing, and essentially we're going to be inserting these foam halves into this plastic centerpiece. It's important to note that this plastic piece is not symmetrical. There is a front and a back, and the easiest way to tell is to hold it up to the light, and you will see an arrow that is molded into the surface of the plastic. That arrow points forward. Now I've highlighted the arrow with a marker on mine to make sure that I always get it correct. Now, joining these pieces together is actually a little bit tricky. The foam is a tight fit into these slots, and the foam is also a little bit fragile. Now, I've tried this several different ways, and I've come up with a method that I think works quite well. Take a medium-sized paperclip and bend it out straight, except for maybe the last inch or so. Then you take the flat part of the paperclip, and you insert it into one of the slots on the wing joiner, and push it all the way to the base. And this will pry open the tabs of the joiner just enough so that the wing is easy to insert. And once you have the wing panel in place, you remove the paperclip by sliding it out of the back. And then you can carefully push the wing all the way to the base of the joiner. Then you repeat that process with the other wing panel in the other slot. I have to admit that before I figured out the paperclip method, I actually damaged one of the wing panels on one of my Betas. I pushed a little bit too hard and crushed the foam somewhat. Now, if the same thing has happened to you, don't worry, I'm going to show you how I fixed mine. I cut away the damaged area of the one wing panel with an X-Acto knife, making sure that my cut was perpendicular to the back side of the wing. I then cut away the same amount of material from the undamaged wing panel. I then applied a strip of scotch tape over the cut and wrapped it around the edge. I did that for both of the cut wing panels. I was then able to insert these perfectly good, although slightly smaller wings, into the joiner using the paperclip method. Now let's talk about the tail surfaces. The horizontal stabilizer is integrated with the plastic mount, which allows you to simply push it into place on the top of the fuselage. The vertical stabilizer is a little bit different, however. It comes with a strip of two-sided tape, and the instructions talk about using that tape to stick the stabilizer to the outside of the fuselage. As I mentioned before, the fuselage also has a slot which can be used for the vertical stabilizer. I recommend using the slot. Now, to do that, you want to peel the tape off of the foam first, and then you simply slide the stabilizer into the slot very carefully. And while the exact positioning of the stabilizer is not very critical, you just want to make sure that this trim tab is fully exposed on the top side of the fuselage. The propeller mount should slide relatively easily onto the front of the fuselage. I have two Betas here, and on one of them, that fit was not very easy. So I corrected that by lightly sanding the front of the fuselage with 200 grit sandpaper. On both of my betas, I noticed that the propellers were out of balance. And you can check this on yours by holding the fuselage horizontal, and you hold the propeller horizontal and release it. If one blade consistently drops lower than the other, your propeller is out of balance. Now, one easy way to correct this is by adding small pieces of scotch tape to the back side of the light blade. And you repeat this until the propeller remains horizontal when released. The instructions talk about center of gravity, but don't go into much detail. So basically, center of gravity is the front-back balance point of the model, and it's one of the more critical elements that will affect how the airplane flies. So first of all, make sure that the rubber motor is in place when you check your airplane's center of gravity. The instructions suggest placing the center of gravity about 1/3 of the way back on the central line of the wing, and this would normally be a safe and stable location for the center of gravity, but the Beta is a little bit different because it has a lifting horizontal stabilizer, and that's like having a whole other wing in the back of the airplane, and this affects where the center of gravity should be located. Now, in my testing, I found that the Beta flies much better with the center of gravity further back than that 1/3 point. So using the wing mount as a guide, I suggest that you start out balancing your airplane on the 4th hole back on the mount. The instructions give you a suggested size when using the 1/8 inch rubber, but they do not cover the 3/16 inch rubber. And there are a lot of variables that will determine the size of the motor that you ultimately want to use, but I will give you my example just to give you a reasonable starting point. The 3/16 inch motor on my Beta is a 13.5 inch loop, so it requires 27 inches of rubber for the motor, plus an inch or two extra for tying the knot. These rubber motors are not like your standard office supply rubber bands. They require a lubricant to work properly and to prevent them from sticking to themselves. Just wind one of these up without the lubricant and you'll see exactly what I mean. One thing to keep in mind is to make sure that the knots for your rubber loops are tight and secure before you add the lubricant, otherwise the knot may slip out. The lubricant suggested to me is called Silglide. This is a silicone-based brake lubricant that you can buy at an auto parts store. And the suggested method for applying Silglide to the rubber strips is to take a Ziploc bag and apply a bead of the Silglide inside the bag, and that bead should be 1/2 inch to 3/4 inch long. Then drop the rubber into the bag and close the bag. Then use your fingers to squish everything around until the rubber strip is completely coated with the lubricant. Then open the bag and pull the strip out using the lip of the bag as a squeegee to remove any excess lubricant from the rubber. Now let's talk about winding the rubber motor. As before, there are a lot of variables that will ultimately determine how you want to load your motor. My goal here is to give you a starting point. So we're going to aim for 66 turns for every inch of loop. We have a 13.5 inch loop. If you multiply that by 66, you get 891 turns. Let's just call it 900. So we're aiming for 900 turns of the rubber motor. Remember, however, that we have a 20-to-1 winder. So if you divide 900 by 20, we're going to be turning the handle 45 times. If you don't have a helper, you will need some sort of stooge to hold the airplane while you wind it. And I've got a simple stooge set up on my workbench here. So I'm going to connect the hook end of the winder into the rear of the motor loop. Now I'm going to pull the motor to about 3 times its resting length. And from here, I will start the winds. And my goal is to move the winder closer to the airplane as I wind. And what I want to do is end up with the rear of the motor at the motor peg just as I'm finishing my 45 turns. It takes a little practice. Once I've reached the 45 turns, I want to pinch near the end of the rubber loop and allow a few turns to come off. And this will loosen the rubber loop enough that I can place the end of the loop over the motor peg. You should now have all the information you need to take the Beta out flying. Just make sure that you find a nice wide open location and that you go on a calm day. The instruction manual talks about trimming the Beta by adjusting the wing's location or using the built-in trim tabs. That's one of the great things about this model. You can make those types of small adjustments and then immediately see how they affect the airplane's flight performance. You could have a few so-so flights in a row, and then you adjust the center of gravity a little bit and have a tremendous flight. And for me, those are the types of lessons that really sink in. So I hope this video helps to give you a successful start with the Beta. Even more so, I hope that the Beta gives you a successful and enthusiastic start in aero modeling. Thanks for watching.